good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. Like I said in the previous video, I said that you should make sure you practice these questions beforehand so that you can compare your answers with how I'm going to answer this question. Okay, so we're answering question 2 in this video. If the gradient on the curve y is equal to ax plus b over x at the point -1, -1 is 5, they want us to find the values of a and b. Okay, so we write the equation y is equal to ax plus b over x. So if the gradient on the curve, okay, so I simply just try to say that m is equal to 5 at the point -1, -1. So at the point -1, -1 is 5, find the values of a and b. The first step is we find the dy dx, or the derivative, okay? Dy dx would be equal to, here we have power 1 multiplied by a will be a, then the power 1 minus 1 will be 0, so we just remain with a. Alright, okay, let me not do it like that, you might get confused of what I might do next. So let me just write it like this. Y is equal to ax plus b over x. So y is equal to ax plus b the power, plus b x the power -1. Why have I done this? When you're differentiating, make sure that the equation is linear. Okay, linear. There are no fractions. You can't differentiate a fraction, something that is down underneath. The denominator there, we need the x to be up in the linear form here, straight line form, just up. It should be like in this form, okay? Not like this. You can't differentiate like that. You can do it in your head, but it's allowed. If you not do it in your head, you can do it in your head. But if you need to show the working, you do it like this. Your dy dx would be equal to, so dy dx is equal to a, like I said. So then you remain with the power 1 times a will just be a. 1 minus 1 is going to give you 0. Then here, minus b, x, then -1 minus 1, -2. Dy dx is equal to a minus b over x squared. So a minus b over x squared, this is your dy dx. So this is the function, okay, that will help you to get the gradient function. Okay. And then we are going to say in this function, we'll say m is equal to a minus b over x squared, because this represents the gradient. Okay? When we get from the coordinates, so when x is equal to -1, m is equal to 5. M is equal to a minus 5 over -1 squared. So negative number, always make sure to put it in brackets or parentheses. Okay? 5 is equal to a minus b over 1. A minus b is equal to 5. This is your equation 1. So you have found the derivative. And that's the equation 1. Just like that. So when you do all that, someone might be confused. What do we do next? Which other information have we been given? So in additional mathematics, you should be able to see. You should be able to see hints, okay, of how to solve. So here they have given us this point here. This particular point, -1, -1, will help us to form the second equation so that we can solve this equation 1 and that second equation simultaneously. Okay, so what am I saying? This equation, we put it there. Then now we proceed to find equation 2. So we have this here, which is y is equal to ax plus b over x. Then the coordinates are there, so we'll say -1 for the, because this is the x coordinate, that's the y coordinate. So -1 is equal to a, you multiply by a -1 for the x, plus a b, you divide by a -1. So -1 is equal to -a minus b. So in this particular case, there's one thing that you need to know. You can multiply the equation throughout by -1. Okay? It does not change the meaning of the equation. It's still the same, and you find the same answer. So maybe you can solve simultaneously with negatives, but for me, I'll solve with positives. So what am I saying? -1 is equal to -a minus b. We multiply by a negative throughout. We're going to have 1 is equal to a plus b. A plus b is equal to 1, equation 2. That's your equation 2. So a plus b is equal to a 1. That's your equation 2. Then we solve these two equations simultaneously to find the values of a and b. A minus b is equal to 5. A plus b is equal to 1. So the simplest to eliminate here is b. Since there's a positive b there, there's a negative b there, so we just put a plus here. So to be a plus a is a 2a. 5 plus 1 is going to give you a 6. Divide by 2, divide by 2. 2 can go into itself 1, 2 can go into itself 1, 2 can go into itself 1, 2 can go into 6, 3. A is equal to 3. Then we'll say let a be equal to 3 in any one of these two equations. You let a be equal to 3. So we'll say in a plus b is equal to 1. So 3 plus b is equal to 1. B is equal to 1 minus 3. So this is 3. B is equal to a -2. Therefore, A is equal to 3, B is equal to a -2. That's your final answer. So A is equal to a 3, B is equal to a -2. This marks the end of this video, and it also marks the end of the practice questions under the dy dx. And the next video, we're going to look at composite functions. We're going to look at something we call the chain rule in the next video. Very important under differentiation. So we're going to look at composite functions, the chain rule. First of all, before I end the video, I sincerely would like to thank you for your support. Having 29 subscribers, that's since the last time that I checked. Upon making this video, we had 29 subscribers, and I hope that we can continue growing and that I can continue educating. Thank you for your support. Thank you so much for watching this video. This has been Cornelius Subinda with another video, and bye bye.